welcome to another video lesson with Kenneth Roosevelt. This concept is solving a linear inequality, problem type 3, as defined by Alex. So, the example Alex provides in their explain menu or option is negative 2x plus 19 is greater than or equal to 3. And right away I can see the problem that some of you are probably having with this. Let me minimize that. And I'm going to move this guy over. A lot of times when we're solving these things, we forget one very important rule of solving inequalities. And that rule I'm going to demonstrate over here. Let's start with two things that are unequal. Say 3 and 5. 3 and 5 are not equal, so I can't put a equal sign between them, but I can certainly put a less than or equal to sign. And this less than or equal to sign will remain true through a variety of transformations that I can do. I can add 2 to both sides. 3 plus 2, which is 5, is still less than or equal to 5 plus 2, which is 7. So we see the addition property of equality works even though it's no longer an equality, it's an inequality. But we're allowed to add equal things on both sides, and that doesn't negate or make false the less than or equal symbol relationship. Okay, let's see what happens if I multiply. If I multiply this by 3 and that by 3, then I see 15 here and 21 there, and I note that 15 is indeed less than or equal to 21. So even that is still true. Will subtraction work? Or adding a negative? Yeah, adding a negative seems to work. I get 10 is less than 16. So all these laws of equality seem to be working for inequalities just as well. However, we do run into a problem a little ways down the road. Let's try dividing. Let's see what happens. 10 divided by 2 is 5, which is less than or equal to 8. Is that true? Yeah, it is. So that's not a problem. In fact, you won't run into a problem when you add, when you subtract, when you multiply or divide, unless you are multiplying or dividing by a negative. If I change one little number here, one little thing, if I put a negative there and a negative there, if I'm dividing both the left and right hand sides by negative 2, I get negative 5 is less than or equal to negative 8. And when I check that on a number line, here's 0, 1, 2, 3, 4, 5. Here's negative 5. Which way is negative 8? It's that way. It's to the left. Negative 8 is to the left of negative 5. Therefore, negative 5 is greater than or equal to negative 8 would be true. What it says right now is not true. Because the fact of the matter is when you multiply or divide by a negative, you change everything to its opposite. And in doing so, the sign that used to be true is now no longer true unless you turn it to its opposite as well. So, and what I mean by the opposite, I mean in the opposite direction. So this less than or equal to sign that we see right here, when we divide it by the negative 2, should have become a greater than or equal to sign. We have to swap the direction when we're multiplying or dividing by a negative. I've proven it or demonstrated it here for dividing. Let me demonstrate it to you for multiplying. Let's take two things. We'll say 1 is greater than negative 2. $1 in your account is much better than negative $2 in your account. But let's multiply both sides by negative 3. So I'm going to go everything times negative 3. So negative 3 times 1 is greater than negative 3 times negative 2. Let's check that. Negative 3 is greater than negative 3 times negative 2 is negative 6. Negative 3 is greater than negative 6. It is. So what did I do wrong? Negative 3 times negative 2 is not negative 6. It's positive 6. See, even I make silly mistakes. So negative 3 is certainly not greater than positive 6. So we see in another example that once again, if you multiply or divide by a negative and you fail to switch the direction of the sign, then your answer will come out wrong. If I flip the direction of the sign so that instead of saying greater than, it says less than, negative 3 is less than 6, it's true. But when I failed to flip the sign, it was false. So you want to make sure as you're solving a problem like problem type 3, that you not only minus 19 on each side, which will cancel that, and you're left with negative 2x is greater than or equal to 3 minus 19 is negative 16. But in this step right here, I'm going to have to divide out the coefficient, which is negative 2. And the moment I divide by negative, I have to flip that inequality symbol to the opposite so that it points the opposite way. Those cancel. X is less than or equal to 8. And if they want us to represent that on a number line, we can go, here's 0, 2, 4, 6, 8. Here's 8. I'm going to fill in that circle because it includes 8. It says x can be equal to 8 or less than 8. So I can go like this, less than or equal to 8. Another way of representing that is with a bracket. Sometimes they use a bracket and then draw in their arrow pointing to the left for less than or equal to 8. They also sometimes put it in interval notation, which you'll learn if you haven't already. The x is anywhere between negative infinity and 8. 8 gets a bracket because it includes 8. Negative infinity gets a parenthesis because you can't really um, you can't really include infinity as an endpoint in a set because it's not really included because you never reach it. So that would be interval notation. And that's it. I hope this was helpful. If you'd like an additional example, I will do that now. Otherwise, you can stop this video and go to a new page. Let's make up another one. 5 minus 3x is less than 8. And this might not come out pretty, but all the same. First of all, we minus the 5. Those guys cancel. We're left with negative 3x is less than 13. Less than or equal to 13. The moment I divide out the coefficient, which is negative 3 here, I have to flip the direction of the inequality. That way everything stays true and there's not a moment in there, hopefully, in which I'm wrong. X is greater than or equal to, now you can write that fraction as it is, or you can write it as it's an improper fraction. You can write it as a mixed number. You could say negative 4 and 1/3. And to graph that, I would have to go somewhere between negative 4 and negative 5 is this number, 4 and 1/3. It includes that, but x can possibly be greater than that. So the solution set for this inequality is anything to the right of negative 4 and 1/3. So as an interval notation, I would write it like this. Well, that should be negative 4 and 1/3, comma, infinity. And when infinity doesn't have a negative next to it, we assume that we're talking about the positive infinity, which is all the way to the right. So x can be anywhere between -4 and 1/3 and positive infinity. Okay, that's it.